Okay, welcome everyone one more time. Make sure you turn on the camera. So today we are working on piecewise defined function. Okay, we'll be working as piecewise defined function. So this lecture is going to be a little short compared to the previous week because we don't have much to cover in this small section, but we are going to look through the piecewise defined function and its components. Okay. So let's first look at the definition of piecewise defined function. When I say piecewise defined function, it's a function defined by multiple sub-functions in the domain. For example, here, if you look at this first graph, you can see that for all values less than 0, okay, for all values less than 0, the graph is going down, right? The graph is going down, or the equation of that graph is y equal to negative x. Okay, for this piece, the equation is y equal to negative x. Similarly, for this one here, the equation is, you can see for this part, the equation is y equal to x. For that part, y equal to x. That means the function is defined piecewise. For all values less than 0, the function is y equal to x. And for all values, you can see more than 0, the function is y equal to x. Okay. Similarly, let's look at the second function here, the second graph. If we look at this graph here, you can see for this part, for x less than 1, everybody look at the screen. For x less than 1, here is 1. For all x less than 1, this is the graph. This graph is y equal to x squared. So you can write down there, that is y equal to x squared. And here, again, you can see between 1 and 2, here is 1. Look at the screen, everybody. Here is 1, here is 2. Between 1 and 2, there is a constant function. The value of y is always 3. That means the equation for that is y equal to 3. And then for this one, you can see this is 2, 2, x and y are equal. If you look at this point, 3 and 3. If you look at this one, 4 and 4. That means this line, which is for x greater than 2, is y equal to x. Y and x are equal. So if you see a function defined piecewise, okay, defined piecewise, then we call it piecewise defined function. So the definition is a piecewise defined function is a function defined on multiple sub-functions. There are little functions within the function, where each sub-function applied to different interval of the domain. And this one here is the example of the absolute value function. The first one is this one. If you just look at the graph, this is the absolute value function. Absolute value function is negative x when x is less than 0. That's why y equal to negative x. And a value of the absolute value is positive x for x greater than 0. So that is y equal to x. Similarly, now we have seen the equation for this one. If we want to define that, if we want to write the equation, we write it like this: f of x equal to, everybody look at the board now, look at the screen. So this one is defined on 3 intervals. If x is less than or equal to 1, 1 is also included, you can see the dot, okay? Less than or equal to 1, the function is x squared. So we say that f of x equal to x squared if x is less than 1. And then from 1 up to 2, between 1 and 2, it is 3. So the value of the function is 3 if x is between 1 and 2. You can see 1 is not included because there is a hole, and 2 is included because there is a dot, right? So we can write that as 1 is not included, so less than x is less than or equal to 2 because 2 is included. So 3 for x between 1 and 2, that is the meaning. And for all values greater than 2, 2 is not included, there is a hole. For all values more than 2, the function is y equal to x. So f of x equal to x if x is greater than 2. So you can clearly see the domain for this function is everything from negative infinity up to infinity. But in each part of the domain, like for x less than 1, the function is x squared. Between 1 and 2, the function is 3. And for x greater than 2, the function is x. So if you see a function defined in small pieces like this, then we call it piecewise defined function. Okay, so that is the basic definition of piecewise defined function. Make sure you copy everything from this screen. And if you have any question, you can ask me now. You can send your question through chat. If you don't have questions, finish up this writing. I'm going to pause here for a second and we'll move on. Okay, before we move on, there is a question in the chat. How do I write these equations, y equal to x squared, y equal to 3, and y equal to x? In fact, we look at the values of the function. For example, over here, for this part of the function, you can clearly see this is a quadratic function or parabola, which is y equal to x squared. And you can also see when x equal to 1, y is also 1. That means 1 squared is 1. Similarly, you can see here when x equal to negative 2, 2 squared is 4. So negative 2 squared is also 4. So you can clearly see that every y value is squared of x. That's why this function is y equal to x squared. For this piece here, the function is not increasing or decreasing. It's constant. The value remains always 3. That's why y equal to 3. And for this function, if you look at this point, it is 2, 2. This point is 3, 3. This point is 4, 4. Meaning of that is y and x are equal. So the equation will be y equal to x. Okay, so we can look at the graph and then we can write the equation. Okay, let's move on to the examples now. So here is our first example. Please copy the question now. And we are going to work on it. So in this one, we are asked to sketch the graph of this function, f of x equal to x squared if x is less than or equal to 1. And then 3 if x is between 1 and 2. And then y equal to x or f of x equal to x if x is greater than 2. So you can clearly see that this is a piecewise defined function. And the function is defined in 3 different pieces, okay? So if I want to represent the pieces using a number line, so I can quickly draw a number line like this, going from, number line going from negative infinity up to infinity, negative infinity up to infinity. And then you can see we are talking about the value of the function for x less than or equal to 1. So 1, and then between 1 and 2. Okay, this one is between 1 and 2. And after that, we have the value of the function for more than 2. So that means in this interval, everybody look at the screen. For this interval, for x less than 1, the function is defined as x squared. That means in this first interval, the function is y equal to x squared. Okay. And in this interval from 1 up to 2, the function is always 3. That means y is equal to 3. The value of the function is always 3. And for x greater than 2, the function is x. That means the function is y equal to x. So that's what you can write in that third interval, y equal to x. So this is how the function is defined on different intervals. What we are asked to do is we are asked to graph the function. Okay. So in order to graph this first function, what you have to do is you have to take all values of x that are less than 1. So if you make the table of values with x values like -3, or let's start at -2, -2, -1, 0, and 1. We have to find what are the y values. This is for the first piece. Okay, this is for the first piece, which is y equal to x squared. So this one is for this first piece, x squared, or y equal to x squared. So that's for the first piece, because that is defined for x less than 1. You can see I have taken 1, 0, -1, -2. Those are the values less than 1. Now, if you want to find the values or the y values for that function at these different x values, then what you will see is, say, if you plug in -2, -2 squared, that will be 4. If you plug in -1, -1 squared is a 1. If you plug in 0, 0 squared is 0. Similarly, if you plug in 1, 1 squared is also 1. So those are the values. So let's try to plug in those values. See, this one is 1, 1. Look at the screen, 1, 1. And you can see 1 is also included because here we have less than or equal to 1. So that point is also included. So 1, 1 is here. That is included. So we'll put a dot there. The next one is 0, 0, which will be here at origin, where I'm pointing, right? 0, 0. Next one is, you can see -1, 1. So let's plug in -1, 1. Here is -1, 1. And then finally, we have -2, 4. So -2, 4 will be, it will be up there, right? -2, 4. So what we do is we draw the graph for this part of the function. So it's like this. It will continue to negative infinities because these values goes all the way up to negative infinity. That's why we have to put the arrow here. You can see the arrow at the end, indicating that this graph extends all the way to the negative side. Okay. So that is the first piece. That is y equal to x squared. That is y equal to x squared. Now for the second piece, see, from the values between 1 and 2, if you look at the screen, for the values between 1 and 2, the value of the function is always 3. So here is 1, here is 2. Between those two, the value of the function is always 2. Okay, so here is 1, 2 is up there. So we start here and we go up to there. See, it's always 2, right? It's not changing, it's horizontal. But remember one thing, you can see that if you look at this interval, this 1 is not included. There is not equal to sign with 1. 1 is not included. That means here at 1, you'll put a circle like that to indicate that the value is not included. But on the other end, you can see there is less than or equal to 2. That means the upper end is included. So you'll put a dot there. The dot indicates that the value is included. So I don't need to make the table for this one, for the second piece, because it is always 3. But you can make the table for this one, for y equal to x. So let's make the table for y equal to x. And we are making table for the values greater than 2. So you can start at x equal to 2, then you may go to 3, 4, and so on. And we find the y values. So let's make that table. And then you can see that the values of x and y are equal. That's the meaning of y equal to x. They are equal. So that means when x equal to 2, y is also 2. When x equal to 3, y is also 3. When x equal to 4, y is also 4. So we're going to put some of these points. The first one is 2, comma 2. So let's plug in 2, comma 2. Hold on. One thing here, I just missed a little thing here. See, for this interval from 1 to 2, the value of the function is 3. It's 1, 2, 3. So this should be a little bit up, right? Okay, so that's something I missed. Let me redraw that quickly. I draw at 2, but it's 3. 3 is this one. Little bit up like that. Because it is 3, not 2. Okay. If we count, here is 1, here is 2, here is 3. So that should be the line there. Okay, now let's graph this one. Y equal to x. The first one is 2, comma 2. Let's plot that point 2, comma 2. 2, comma 2 is here. This is 2, comma 2. But you can see that 2 is not included because it is for the values greater than 2. So in fact, over there, we draw a circle like that. Okay, we draw a circle to indicate that the values are not included, or that particular value is not included. That's why we draw a circle there. And then the next one we have is 3, comma 3. So let's plug in 3, comma 3. 3, comma 3 is right there. You should see that dot there. And the next one is 4, comma 4. Which is a dot up here, you can see. Okay, this is 2, comma 2. This is 3, comma 3. This is 4, comma 4. But if you look at the value here, these are for x greater than 2. So 2 is not included. So at 2, the value is not included. That's why there is a hole there. And it takes all values. If you look at this interval, when I say x greater than 2, that means all values more than 2 up to infinity. I draw 3 points here. I can join those to get the graph, but the graph will continue forever. So we must have the arrow over there. We must have that arrow over there to indicate that the graph continues all the way to infinity. Now you can write the equation for this middle portion. It was y equal to 3. It was y equal to 3. And for this one, that is y equal to x. So this is y equal to x. So we sketch the graph for the function. So quick question here in the chat is, how do I know, the question is, how do we know 3, comma 3 and 4, comma 4 are included and 2, comma 2 is not included? Okay, so see, if you look at this one, we got these points 2, 2, 3, 3, 4, 4, which is the values of the function at x equal to 2, 3, 4. They are equal. That's why x and y coordinates are equal. But now, if you look at the way the function is defined here, see, the function is x, that is y equal to x, if x is greater than 2. It is not saying that greater than or equal to. Okay, so that means because there is not equal to here, that particular value is not included. Just that 2 is not included and everything else is included because the function is defined from 2, but that particular value 2 is not included, but everything else are included. That's why 2, comma 2 is not included, but everything else after that, they are included. So it's really important to look at the end values. Okay, whether that particular end value is included or not. All those intermediate values will definitely be included, if that makes sense. Okay, if you have any other question, you can send me through chat. If not, finish up your writing. We'll move on to next example. Okay, look like there is no question. Aditi, are we done copying it? Yes, okay, good. Let's go to this one now. Here is the function. It is given as a piecewise defined function, and we are asked to evaluate the value of the function at different points. So first, copy the question. I'm going to give you 1 minute to copy the question, and then we'll start working on it. Okay, I know you're done copying this, so let's get started with this one. So what we do first is we are going to analyze this function properly. See, f of x is defined in 3 different pieces. And then the way it is defined is for x less than, see, for x less than 0, it is 5x. Does this make sense? For x less than 0, meaning of that is, see, if I want to write that function a little differently, this is what it is. F of x equal to 5x. Okay, everyone look at the screen. F of x equal to 5x. If x is less than 0, when we say less than 0, that means the values are from negative infinity up to 0. But you can see that there is not equal to sign there. That means 0 is not included. Does that make sense? This is defined for all negative values. Okay, this is defined for all negative values. So x values are all negative. X values are all negative there, because the function is defined from negative infinity up to 0. 0 is not included. So all numbers less than 0, they are negative numbers. Okay, that is the meaning of the first piece. The second piece is the value of the function is 3. You can see there, the value of the function is 3, and this is for all values between 0 and 3. See, 0 is included, less than or equal to 0. 3 is also included. So this is for all values between 0 and 3. Okay, all values between 0 and 3. Even 0 and 3 are included. So all x values, I should write, all x values between 0 and 3. And here 0 and 3 are included. 0 and 3 are also included. That is the meaning of that. So you really need to understand the meaning of the piecewise defined function that is given here. We put the parenthesis around infinity all the time. That's one thing to know. And then for the fixed values, if the value is not included, we put parenthesis. And if the values are included, we put the bracket. Okay, we put bracket if the values are included. We put parenthesis if the values are not included. That was Prakriti's question in the chat. Prakriti, do you understand that? You can reply in the chat if you want. Okay. Good, thank you. At infinity, it is always parenthesis, okay? And when we say here in the first one, when we say x value is less than 0, we are talking about all values from 0 all the way up to negative infinity. That's why negative infinity up to 0. And then if you look at the next one here, f of x equal to x squared, f of x equal to x squared, and you can see that this is for x greater than 3. 3 is not included, but all values more than 3. So that is from 3 up to infinity. All values more than 3. All x values more than 3. And here 3 is not included. 3 is not included. So what we have done so far is we learned to understand this function. How is this piecewise defined function works, right? Actually, what are the meaning of this little domain there, or what are the meaning of this little interval there? We look at that. So we have the meaning of all these. So if the values, say, if the values of x are in this interval from negative infinity up to 0, our function is 5x. If the values are from 0 through 3, the function is always 3. And if the values are more than 3, then it is x squared. That is the meaning. Okay, now let's try to answer this question. So when you're answering this question, I will call your name. I want you to unmute yourself and help me write the answer. Yes, Vidya. Maybe you'll be called first. I can see your face there. Okay, so the first one, see, we have the first one is we are asked to find f of -1. So let's write that down. We want to find f of -1. When we say f of -1, okay, Vidya, you can unmute yourself now. And tell me, so to find the value of the function, you know that we plug in the value into the function, right? But where do we plug in -1? Do we plug in to the first one, the second one, or third one? Where do we plug in? Where is -1? Is -1 in the first interval, the second interval, or third interval? What do you think, Vidya?
First one.
The first interval, that's right, that's right. Because in first interval, x values are all negative. So what we do is we plug in -1 into the first function. So if we plug in -1 there, that will be 5 times -1, which is equal to -5. So the value of the function at -1 is -5. Okay. So we did the first one. Now, the second one is f of 0. F of 0. Now, let me see who I can ask to. Prakriti, could you please unmute yourself and tell me in which interval do we have 0? 0 is included in which interval?
The second one.
The second one, very good, because 0 is included there. It's from 0 up to 3, and 0 is also included. So the value of the function from 0 up to 3 is always 3. Okay, so f of 0 is equal to 3. Very good, Prakriti. Okay, now the next one we have is f of 2. Look at the screen. We have f of 2. So let's see, f of 2. Sagar, please unmute yourself.
You'd go on the second one.
Which one? 3 is in the, 2 is in the, which interval you said?
fx equals 3, the second one.
The second interval, that's very good. So yes, 2 is also in the second interval from 0 through 3, And the value of the function is always 3. So here also f of 2 will be equal to 3. Awesome. Good job, Sagar. Now we have the last one here. We have to find the value of the function at 4. F of 4. Let's see who I can see in the screen, because when I'm presenting, my screen will be pretty much hidden all the time. That's why it is quite difficult to see all students. Look like Diksha is ready. Could you please unmute yourself, Diksha?
The third
And
one.
the third one, very good. So 4 is in this interval, so we plug into that function, f of x equal to x squared. So it will be 4 squared, because our function is x squared. Our input value is 4, so 4 squared, which is equal to 16. Thank you, Diksha. So this is how we can evaluate the piecewise defined function. So in order to evaluate the piecewise defined function, you must know where a particular piece is defined, in what interval it is defined. Okay. You really don't need to write all these things that I've written here if you understand the fundamental concepts. But I've written it here because when you go back and look at your notes later on, this will help you a lot. Okay. So whenever you see a piecewise defined function, the first thing you should do is you must understand what portion or what function is defined on a particular piece or particular interval. Okay, that is very, very important. Okay, finish up that writing for this example and we'll move on to next one. So maybe I'm going to give you like 30 more seconds. Okay, I know you are done now. Let's go to this one now. There is next example. Here they have given the graph of the function. And by looking at the graph, we have to find the values of the function. Okay, we have to find the values of the function by looking at the graph. So please copy the question and we'll start working on that. So I'm going to give you about 1 minute to copy the question. Okay, let me know when you're done copying. You can send through chat. You can say, yes, I'm done once you're done. Okay, I started getting, I'm done. I'll wait for 1 or 2 more done, just to know that you are all done copying it. Okay, look like everyone is done. So let's work on this one now. This is going to be the last example for today. So in this example, unlike the previous example, they have given the graph. Graph is already given. We have to look at the graph of the function, and then we have to write the values of the function here. Okay, I'm also going to call you this time to help me. So let's see. We have to find, the first one is we have to find the value of the function at -1. I'm going to do this one. See, -1 is here. Everybody look at the screen. -1 is here. And then if you look at the point on the graph at -1, The point on the graph at -1 is here. The point on the graph at -1 is here. And at that point, the y value, because when you're asked to evaluate the value, or if you want to find the value of the function at -1, that is a y value. So for this point, the y value is 1. So f of -1 is 1. So what do we do? At -1, we put a point on the graph, and then we look for the corresponding y value. And that y value is the value of the function at given x value. Okay, so we got f of -1 equal to 1. Now let's see. Next one is we have to find f of 0. So Karina, could you please unmute yourself?
It's 0.
0, that's right, because when you're looking for f of 0, it is the point here at origin. So y value is also 0. So f of 0 is 0. Thank you, Karina. Okay. Next one now, we have to find f of 1. We have to find the value of the function at 1, f of 1. Let me check this with Aditi. Please unmute yourself and tell me, what is f of 1?
F of 1 can either be like 1 or 3.
That's 1. That's right. So when it's f of 1, the point on the graph is this one. That point is included. And the corresponding y value is 1. So yes, f of 1 is equal to 1. Thank you, Aditi. Let's see who I can ask next. F of 2. Samyo, could you please unmute yourself? Samyo Rai. Please unmute yourself and tell me, what is the value of the function at 2? What do you think?
2.
2. Okay. Everybody look at this screen. This is confusing. Thank you, Samir. At 2, you can see that if you go all the way up here, this value is not included, right? That is a hole. This value is not included. The included value is up here. Here is the dot. Okay, that value is included, and that value is actually 3. Okay, so f of 2 is equal to 3. So you have to be very careful when you have values like that. Always see there are two values. The value down here is not included, but the value up here is included. So that is a 3. Over here at 1, you can see at 1, this value is not included, but this one is included. So f of 1 is a 1. Okay. Now we have the last one here, f of 3. We have to find f of 3. And let's see whose turn is this. Chandana.
3.
F of 3 is 3, because when you look at 3, if you go all the way up and put a dot on the graph, that will be the dot on the graph, and the corresponding y value is also 3. So f of 3 is 3. Thank you, Chandana. So if the graph of piecewise defined function is given, what you have to do is to find the value, like here in this one, right, at -1, you have to go to the graph, put a dot, and then look for the corresponding y value along the y-axis, because the values of the functions are along the y-axis, okay, because output values are along the y-axis. These values which are here inside the parentheses, these are the values at which we are evaluating the function. So those are the x values, okay, the values inside the parentheses that are here, those are the x values or input. And then these values that we get here, these are the values of the function or output values. So that's how we can find the values of the function from a piecewise defined function. And also we can use the same concept if any other graph is given. We find the point on the graph, and then we look for the corresponding y values to find the value of the function at given x value. Okay, that is all from this short chapter on piecewise defined function. But don't leave. I'm going to stop this live stream first, and we'll talk a little bit after that. Let me stop.